So hello everyone. Today we are going to start with sheet metal miter flange. So to understand miter flange, first I have drawn two edge flanges here. This first set is for vertical flanges and the other second set is for horizontal flanges. So you can see the outcome of these two sets. The corners are not connected here. Means if you want a miter joint, these corners are needed to be connected at 45 degrees, but they are not connected at 45 degrees. Instead, they are showing a 90-degree angle here. So if you want a miter flange, you can see here the title is given, and with that title, the symbol of miter flange is also given. So we want corner treatment like this in miter flange, so that there is a 45 degrees angle between two flanges and there is a small gap between them. But here they are coming at 90 degrees. That's why miter flanges are needed here. One more use of miter flange. If you see the drawback of edge flange, you can make straight flanges only. But if you want to make a flange that is in curve shape, we cannot use edge flanges there. Instead of that, we can use miter flanges there. So that is also one of the use. So to start with miter flanges, first I'll delete this edge flange 1 and edge flange 2 here. So I'll delete both of them. Now the way to make miter flange is, suppose if I want miter flange on this particular edge, so I need to sketch the face which is perpendicular to this edge. So here you can see this blue edge. So I will sketch this face only as it is perpendicular to the edge. I select the face, say sketch, and while starting the miter flange you have to make a cross sectional profile for that. So I'm making a profile here. Suppose I want two sets, so I'll go for two lines here, vertical and horizontal. Then put up the required values. I'll say it 100 mm and this one as 50 mm. This line was starting from the upper point, you can see here. Now as soon as I say exit sketch, it will be converted into miter flange, which is going to come on this edge first. So I'll exit this sketch. One more thing to note, that when you start this sketch, you don't need to start it from the bottom point. You must compulsorily start with the upper point here. Then only the miter flange will be created. So I'll exit this sketch here and say miter flange, select the required sketch, and now you can see on this particular edge, side edge, this flange is coming here. So I'll change the default radius if I want to change, or else you can keep the default radius here. Go for the flange position. Now the flange position is showing material inside, and suppose if I want to change the flange position as it was in edge flange you have seen earlier in lectures, so you can change the position also here. Suppose I want material outside, I'll take this material outside. Suppose I want this total radius outside, I'll take this radius outside. So in this way you can change the flange positions here. There is a gap distance being shown here, but it will be shown only when we select the second edge. So I'll select this as a second edge, and now you can see this upper corner, there is a gap which is given here, that is 0.25, I'll say 0.5 mm gap, and the joint here is coming as miter joint, that is the both flanges are connected by 45 degrees angle here. There is no gap such as in edge flange was there. So if you want this kind of corner treatment, we'll go for miter flanges. Also one more thing, suppose I want to edit this sketch and make it a curve shape there. So I'll say edit sketch. I'll change the distance value here. I'll say 30 mm. This value as 80 mm. Now I want a curve nature here. So I'll go for 3-point arc. First point, second point, and third point as required. I'll give it a value here. I'll say it 20 mm radius. One more relation here, horizontal. And now when we exit this sketch, it will get updated there. Say miter flange and select the command. So now you can see you can make curve shape flanges also there in miter flange, which cannot be made by edge flanges here. Again, select the all edges. You can see the corner treatment here. It is completely packed, having only one gap at each corner, that is of 0.5 mm, which we have given here at the left side in model tree. Suppose I clear the selection and only select one edge, and I want to drag this miter joint inside from the corner at a particular distance. Then we will go for start and offset. So I'll put up the distance here. I'll say 20 mm. So you can see D1 is from the sketch we have drawn, this distance, and D2 will be the opposite side distance. I want the distance of 20 mm from opposite side also. So now both the sides are been dragged inside here. Said OK, and the miter flange has been created here. You can see the auto relief gap. It is in a rectangular shape. If you want to change it into abound, you can change it into abound here. Go to custom relief type in edit feature miter flange, and you can change the option here as abound. Said OK there. Now it is abound. So earlier also we have explained what is this gap. This is nothing but auto relief gap, which is produced to relieve the stresses which are developed during bending in between the edges. It also avoids the shrinkage of metal here. That's why this gap is given, and the gap value depends on the thickness ratio. So this was miter flange here. I'll delete this and make it one more time. Suppose I want flange on this edge, so I'll go for the perpendicular face, that is this one, front one face. I'll select this face and say sketch, then go for line treatment there, put up the values. I'll say it 70 mm, say it 30 mm here, exit this sketch here, and you can see miter flange has been created. I'll select all the upper edges. You have to note that you have to select only the upper edges. Lower edge selection will not apply the miter flange there. So the corner treatment is coming as miter here. That's why it is called as miter joint. Say it OK. If I want to flatten, I'll go for flatten command here. You can see the corners. Again, exit the flatten. So this was miter joint here. Next command we are going to see here is hem flange. So to start with hem flange, I select the feature here. We don't need to make any sketch for the hem flange. You just need to select the required edges for making the hem. I have selected the left side edge here, and now you can see one hem has been created. There are total 4 types of hem given here. So first we will start with close hem. So this one is close hem. You just have to provide the flange length. So this distance given here is the flange length, that is 15 mm as shown. So this 15 mm will be counted from the quadrant of this circular edge. From this point, the extreme end point of the circular edge, this quadrant point till the straight edges here. You can see in symbol also it is shown. It is been counted from the outer quadrant of the circular edge till the flat face of the other end. So this is the 15 mm distance from this point to this point. Suppose I want to change the distance here. I'll say it 10 mm, and this flange is called as close hem. It is because there is no gap between here. You can see a little bit minor gap, but it is not counted as a gap here. So it will be considered as a close hem only. Next we are going to see here the type is open hem. So in open hem, we have to provide the diameter inside. You can see the diameter given here. So I'll say it 3 mm here, and the length is 10 mm. I'll say it 15. And now this complete hem, you can see the position is coming outside the edge. So if I want this position to be taken inside the edge so as to match the flange base parameter, I'll go for inside hem. I select this option, say inside hem, and suppose I want the bend outside, so I'll go for this option. Next type here it is given as teardrop hem. So this is teardrop hem. It is in shape of a drop, that's why it is called as teardrop hem. In this teardrop hem, there is a limitation of angle. In open hem, the parameters we have given were diameter inside or a gap distance and the flange length. But in teardrop, we are going to give one angle and one radius here. Instead of diameter, we are going to give radius and the angle here. So the angle limit is given here as 180 above and 270 below. So the angle should come above 180 and below 270. I'll take it as 210. This straight portion of the flange will always be bended towards this face. If I change the angle, then also this flange is connected to the face only. I'll change the angle, I'll say 250. Still, the flange is connected here on the face. If I say 190, even then this flange is connected to this face. So these foldings are nothing but hems. We will see the types also here. So these are the types of hem we are seeing there. We have seen flat hem, open hem, and now we were currently seeing the teardrop hem. Next we are going to go for this roll hem. So these 4 types are given in SolidWorks. This rope hem is not given, this type of rope hem is not given in SolidWorks. But if you refer SolidWorks software, then you can get this type of hem also there. Again we'll come to software. So this was the teardrop hem. If you want to increase the curve shape, you have to increase the radius value. I'll say 2 mm or 3 mm here, and change the angle. I'll say 225 degrees, or else I'll say 250 degrees or 230 degrees, or I'll say 210 degrees. Hem inside, and now okay. This was teardrop hem. Now suppose I want to drag this hem inside. I'll again say edit hem feature and go for edit hem width. Drag these points here. Go for smart dimension and select the points. I'll say 30 mm. And on the other side also I'll keep the same distance. That will be 30 only. Say finish. And this teardrop hem has been created here with auto reliefs given rectangular type. So this auto relief and dragging option is given in all options such as edge flange, miter flange, hem flange. Whatever command you take from these three, this option is given to drag these flanges inside the part. The last type we are going to see here, that is hems rolled bend. I'll select the rolled bend, select the required edge, and you can see one rolled hem is been created here. You have to change the angle as well as the radius inside. I'll say 1 mm radius. We'll take 3 mm radius here. And now you can give the angle from 0 to 360 degrees. There is no limitation of angle as there was in teardrop. Suppose I want to edit the hem width. I'll go for hem width, and you need to select the points below points and then drag the hem. Place the required dimension to end the hem at the other side. Say finish, and this rolled hem has been created here. We can see here. This was hem feature for you. Next command we are going to see here is swept flange. It is similar to miter flange only, but in miter flange, corners were created with the gaps there. Ripping gap was given there. But in swept flange, the flanges will be created but without gap. So I'll delete both these hems there. And now I'll start with swept flange. For that I have to make profile on the cross section. Suppose I am going to make one edge flange. Say it OK. And now I select this flange face and directly go for one line here from the outer point. If I want to give an angle, I'll provide the angle also there. I have taken 25 degrees angle and flange length as required. Instead of giving the incline length, we can prefer the length from the bottom side to the top end of the part. I'll say 80 mm here. Exit this sketch and select this swept flange. Profile, I'll select this line, and in edge profile, I'll select this edge, and now you can see this profile is been swept here along this flange till the end. Suppose if I want to give distance from the end, I don't want it complete on the edge, then I can go for this D2 distance here. Second distance I will provide it as 20 mm. So it will take a gap of 20 mm there. And suppose in start also if I want to give the gap, I will go for this D1 distance. In this way also you can create the flange same as miter. Say it OK. And now you can see one swept flange has been created here with auto relief gaps to relieve the stresses and avoid the shrinkage of the metal here. This was swept flange command. So these were the commands we were going to see today. For further commands or next commands, we continue in the next lecture. You can see the previous playlist for the other commands we have seen here. So till then, thank you.